Okay, so today we're taking notes on chapter 5, which is regression. I'm going to go pretty quickly because most of this stuff is what we reviewed in chapter 13. So if I'm going too quickly at any point in time, just let me know and I'll slow down. Okay, correlation. First of all, the symbol is R. That's the symbol for sample correlation. This one is called Pearson's correlation coefficient. So there's a whole bunch of different ways to calculate correlation. We use Pearson. So sample correlation is R. Do you guys remember the symbol for population correlation?
Capital R.
No. No.
So now I got it.
Rho.
Yeah.
Rho. You guys know what rho looks like? It's like a P with a little, a tail, I guess.
So like an R?
What?
But yeah,
You with a little tail? Like an R?
That's rho. Rho.
What are the other simple ways to calculate?
It's not a P, it's a rho. Okay, so, we can discuss this later. It's not important to the AP test. Correlation measures association in linear situations. You have to remember it's linear. So if correlation is 0, it doesn't mean that there's no relationship at all. It means that there's no linear relationship. It's the same sign as whatever the slope is, so positive R is a positive correlation. If R is between negative 0.5 and positive 0.5, it's weak. 0.5 and 0.8 is moderate. 0.8 and 1 is strong. What if you have R equal to 1 or negative 1? Perfectly linear correlation or perfectly linear relationship. Please make sure that you know that correlation does not imply causation. Just because you have an R value of 1 does not mean that one variable causes the other. Okay, do we remember the slope formulas for slope and y-intercept?
Sure.
Yeah.
Maybe, do we actually remember them?
Yeah.
Okay, what's the formula for A?
That's why.
Y
Don't we need B for
minus bx, and then they're both bars.
Y bars.
Y bar
Oh
minus
my gosh.
B, X
Y
bar.
hat.
Okay, so A is y bar minus b x bar.
That's what I said.
B is r times sy over sx. You
Yeah.
guys need to have those memorized.
Yeah.
This is slope, that's y-intercept. Interpreting both, you have to remember that they're both predictions. So this is sample y-intercept and sample slope. These are predictions of the population y-intercept and the population slope. Slope is the predicted change in y when x changes by 1. Of course, you're going to use context. The y-intercept is the predicted value of y when x is 0. That's often useless because why?
It's
What's up?
extrapolation.
Extrapolation. What does y hat mean?
Oh, is that you meant to spell what? You hit?
Yes. Okay, residual is y minus y hat, so what actually happened minus what we predicted. The residual is always summed to 0. If you have a positive residual, it means your observation is above the line of best fit, so our prediction was too low. If you have a negative residual, that means that your observation is below the line, so our prediction was too high. Okay, so determining the fit of a model. So if you do a linear regression, if it's a good model, first thing you want to look at is the residual plot. You want no pattern in the residual plot. So specifically, you don't want a fan, you don't want a nonlinear pattern. What does a fan pattern tell us?
Quadratic?
No. Standard deviation is not a constant.
Yeah, that one.
Okay. Nonlinear pattern in the residual plot would indicate a nonlinear data set. And you don't want any other pattern of any type. Besides that, you're also going to look at the coefficient of determination, which is r squared. This is that sentence that I told you to memorize. So it's the percent of variability in y that can be explained by the approximately linear relationship between x and y. There's one other item that you can look at to determine model fit. What is it? Besides the residual plot and besides the coefficient of determination. What?
I said residual.
It's the first one I talked about.
Yeah, I know. I was thinking.
Well, what's the most obvious one that you should look at? Scatter plot of the data. Of course, you want to look at your data and see if it looks linear. If it does, you're going to fit a model. You're going to look at the residual plot, the coefficient of determination, and SE. standard deviation of the residuals. If it's a good fit, if your model is a good fit to the data, what's going to be true about SE? It's going to be very small, close to 0. It means that all the observations fall close to the line of best fit. So SE is just the typical residual. Remember, it's always in the y direction. It's typically how far observations deviate in the y direction. Extrapolation, this we already talked about. It's when you predict y for an x value outside of the domain that is used to create the least squares regression line. The danger here is you're not sure if your pattern extends that far, so you could end up with a prediction that is right, that's really accurate, but we're not sure if it will be or not. Am I going too fast? No? Okay, so everything that we did is linear regression, but you need to be able to read polynomial regression. So this is normal linear regression. So y equals a plus bx. That's normal linear regression. This one is natural log regression. So natural log of y equals a plus bx. This one is square root. This one is one we talked about also. This is the polynomial regression that I want you to be able to read. So this is a plus bx minus, I guess, c x squared. So this one has an x and an x squared in it. I will never ask you to find this equation, but you do need to be able to read it from the output, including from this part right here. So this tells you constant x, x squared, and then their coefficients. Am I going too fast? No? Okay. Then do you remember talking about transforming data? So we do this least squares regression line. It only works for linear situations. So what happens when you have a data set that's not linear? You straighten it to make it linear, and then you do the least squares regression again. So you look at your scatter plot and you determine, okay, it's not linear. Then you want to transform x, y, or both using the ladder of powers. Do you remember this figure?
Yeah.
This helps to suggest to you how to transform your data set. So if you have a curve that looks like 1, y needs to be taken up, x needs to be taken up, or both. I only transform one at a time. So I might do x squared or x to the third, y squared or y to the third. What would be examples of taking down? Log, square root, reciprocal, natural log. I know you can't see that, but that's basically what that's saying. What you need to be careful of is if you decide to take a square root, make sure you can take a square root of all of your observations. So make sure you don't have any that are 0. If you decide to do a reciprocal, make sure you don't have any zeros there, because you can't take the reciprocal of 0. Log and natural log is only for positive numbers, so make sure your data set doesn't have any negatives or 0. So then you're going to look at a scatter plot of the transform data. Then you're going to do your regression. Then you're going to look at a residual plot. Then you'll determine, is my data linear? Yes or no? If it is, great. If not, you got to go back and do it all over again. You have to make sure that you solve for y. So I never want your equation to be natural log of y equals. I don't want that. I want y equals. Do you guys remember how to transform out of natural log and log? So, like, for example, if we had natural log of y equals 1 plus 2x.
And you took the natural log of y equals e.
So you would get y equals e to the power 1 plus 2x. Right? And if it's log of y, all that changes is this becomes a 10. Vaguely recall that? Okay. And then plot your new equation and then your data set. Okay, you need to know these two formulas. Yeah, they're not on your formula sheet, so you need to memorize them. Okay, quick reminder. You may only input for x. You never input for y. So if you are asked to input for y, what do you have to do?
Get the other equation.
You have to do the regression again, but flip your variables. You guys understand what I'm saying
Yeah.
when I say that? So like flip list 1 and 2 and do your regression again and change the input and the output? Yes?
Yes.
No?
Yeah.
Okay. Do you remember why you can only input for x? The least squares regression line minimizes the residuals. So if you flip your x and your y variable, the residual context flips. Does that make sense? You're looking at the residuals in the y direction, but then if you flip your variables, it suddenly becomes the x direction. That's why you can only input for one. You don't need to know that, but you just need to remember only input for x and never for y. Okay. Last